So we're going to go ahead and switch into our statistics unit. And to start out, we're going to talk about what's called a normal distribution. A normal distribution is a bell-shaped curve. So just like you see in this picture, so it's a bell-shaped curve that is symmetric. Symmetric about the mean. So the mean is always indicated with this variable called mu. It's a Greek letter. And just remember, mean is the average of the data. That's just the basic definition. So you add up all the data points, divide by the number of values. The little weird, this is called sigma right here. That tells you that's how much you vary. So it's the measure of variation. So the amount of variation. Like typical variation, I should say, between, or within, I should say, within the set of values. Okay, so it's just like the typical, and you'll notice you actually, to find each value on the x-axis or the horizontal axis, you first, to go to the right, just add the standard deviation every time. To go to the left, you just subtract the standard deviation every time. So if so these two values are right here. These two locations are called one standard deviation away from the mean because you've added and subtracted just one of the standard deviations. If I say 2 standard deviations from the mean, I've added or subtracted 2 times the standard deviation. So then we've got these percents. The cool thing about normal distributions is that the area under the curve roughly follows the exact same pattern every single time. So the pattern is that the area under this first little part, so within 1 standard deviation of the mean, so in this range, that area is always going to be 68% of the total area. And when you apply it to statistics, that is also telling us that there's 68% of our data will lie within that location. Then you go to the next section, and if you include all the way up to this, the 2 standard deviations out, then you're going to get 95% of your data. If you go out 3 standard deviations, you'll get 99.7% of your data, and then the rest of it would be the remaining 100%. You'll notice that there are these smaller percents along the sides, and they are, because it's symmetric, they copy, they're the same numbers on the other side. To find those, the first one's really easy. The 68, this 34% is just half of 68 because you're splitting that area in 2 equal pieces. So you got 34% on either side. Now the next one is just a little extra step because you'll notice that all 4 of these regions are not the exact same area. It's not the same shaded amount. So to find it, you take 95% and subtract the 68 from it, divide it, split it in half because there's 2 sides that are equal, and that's where you get the 13.5%. Likewise, to find 2.35%, I'm going to take the 99.7, subtract it from 95, and then split it in half because there's 2 sides since it's symmetric, and you get 2.35%. And then finally, you always have, there's got to be somewhere there's going to be the rest of your data. So 100% minus 99.7, split that in half, and that's where you get the 0.15% at the tail ends. So that is where those other percentages come from. So let's see how to apply this. Now, when you go into problems, it is really important that you check to see what word they use. Do they use the word percent or do they say probability? Percent is going to be something greater than 1, greater, well, it doesn't necessarily have to be greater than 1. A percent is going to be just like these values right here. along the curve. But if I say probability, the values always have to be less than 1, so you change the percent to a decimal. So this first one is a percent, so we can just use the exact numbers that are off the curve. And if you base this off the curve, if you go back and look at the percentages, this would be 34%, this would be 13.5 in that shaded region. So if you add those two together, you get 47.5% of your data. So number 2, same idea, because we're just going to the shaded region. So it's always good to know where your middle is. That's my middle, so I'm going 2 over, because this is 34. So this one's 13.5%. So now I'm going to take 13.5. That means this one's also 13.5, which we don't need. We don't need that 34. So this is 2.35%. And then we've got this little tail end part that's 0.15%. Add those together and you get that the shaded region includes 16% of your data. Let's go to the next one. Same idea, so it's going to go 34, and then this is 13.5, and that's 2.35. So if you add those two together, and notice it doesn't include this little tail end, so we don't put the 0.15% in, you get 15.85% of your data. Then number 4, both of these are just 34%, or the whole should be 68% because they're on either side of the mean. All right, so like I said, we're doing the same thing, but now we have to just make sure our final answer is not in terms of a percent, but a decimal. But otherwise, it's exactly the same concept. They will write it this way, so we're trying to find the probability, that stands for the probability, that x is greater than or equal to the mean plus 3 times the standard deviation. So we're just going greater, so that's over here, which includes the 0.15%. So the probability, if it's 0.15%, to change that to a probability, you just move the decimal place over 2 spots, and you get 0.0015 as your probability. Number 6, let's erase that. So number 6, we want the probability that x is less than or equal to the mu minus 2 times sigma. So, or the mean minus 2 times the standard deviation. So we're going right here. So I'm going to do the percents first, and then I'll convert it. So we'll find the percent. If you add those two together, you get 2.5%. And then just remember, you need to move that over twice to find your probability. Oops, don't want to use that yellow the whole time. And you get 0.025 as your probability for that one. All right, next one. This one's going between 2 values, so we're going between this value right here and the mean right here. So we're just doing everything in between. And I'm going to do the percentages first. So we've got 13.5% plus 34%, which is 47.5%. And once again, because the question asked for a probability, we're just going to convert that to a decimal. So we get 0.475. And then last one in this set, let's erase all that. It's another one where we're going between, so we're going between this one and this one right here. We're just going to add all those together, so 34 plus 34 is 13.5 plus 2.35. Not the 0.15%, so be careful about that. Sometimes people accidentally add an extra one in. So you get 83.85%, and once again, we need to change that to a decimal, or to a probability, which is always a number less than 1. And there you have it, 0.8385.